Hey guys, today we're going to talk about what happens when you multiply a monomial by any kind of polynomial. So if you'll take a look at number 1, I have a monomial of 3 being multiplied by a binomial of x plus 5. Well, this is nothing like you haven't seen before. This is just basic distribution. We're going to take this 3 and we're going to distribute it through that binomial. So 3 times x gives me 3x, and 3 times 5 gives me 15. Now, the one thing that I want to make sure that you guys do every single time is before you move on to the next problem, I want you to double check that this guy's into standard form. So my first term has a degree of 1 because the exponent is 1, and my second term has a degree of 0 because there is no exponent, so that it is in standard form. On number 2, I want to take this 2y, so I have a monomial being multiplied by a trinomial. I want to take this 2y and distribute it throughout my trinomial. So I'm going to take that 2y times 3y squared, and remember when you do that, you multiply the coefficients to get 6, and you add the exponents to get 3, so 6y to the third. Then I'm going to take 2y times 10y, again multiply the coefficients to get 20, add the exponents to get y squared. And then finally I'm going to take that 2y times negative 6, and I'm going to get negative 12y. Again, before you guys move on to the next problem, double check that it's in standard form. So I have a degree of 3, a degree of 2, a degree of 1, so it is in standard form. Now, just a quick refresher, the degree of this polynomial is 3, and the leading coefficient is 6. On number 3, I just have a basic monomial times a monomial, so I'm going to multiply those two together, and I'm just going to get 8x squared, because I multiply the coefficients and add the exponents. On number 4, when I distribute this 4x throughout my binomial, I'm going to take 4x times 2, and I'm going to get 8x, and then I'm going to take 4x times x, and I'm going to get 4x squared. Now, on this one, I hope you'll notice that the degree of my first term is 1, but my degree of my second term is 2, so this is not in standard form, and I need to switch them places. My 4x squared needs to go first, and my 8x needs to go second. So, on number 5, let's try again. I want to start by distributing this negative 4 throughout my trinomial. So, negative 4ab times a squared. I'm going to start with the coefficients. Negative 4 times 1 gives me negative 4. A times a squared gives me a to the third, and I only have one b term in this whole problem, so I'm going to drop it on down. Now I'm going to take that negative 4ab and multiply it by negative 6ab. So negative 4 times negative 6 gives me a positive 24. A times a gives me a squared. B times b gives me b squared. So I have 24a squared b squared. Finally, I want to take this negative 4ab times 9, and that just has me dealing with the coefficients, so I'm going to have negative 36, and then bring down my ab. Now I want to double check the degree of my polynomials and make sure that they're all in order. So I have an a to the third, b to the first, so I add those together and I get a degree of 4. I have a squared, b squared, add those together and I get a degree of 4. And I have a to the first, b to the first, and I have a degree of 2. So in order of 4, 4, 2, this is in standard form. On number 6, I have 2m to the fourth times the quantity of m to the fifth minus 3. I'd like you to pause the video and do that one on your own. Hopefully when you distribute through, you see that you get 2m to the ninth minus 6m to the fourth. Now let's look at number 7. On 7, we have 8 times the quantity of x plus 9 plus x. So we're going to start just like normal. We're going to start by distributing. I'm going to take that 8 times x, and I'm going to get 8x. And then I'm going to take 8 times 9, and I'm going to get 72. But since this x is not inside of my parentheses, I don't need to be multiplying it by my coefficient of 8 over here. I'm just going to bring it on down. And now if you look, I have an equation of 8x plus 72 plus x. Now I have like terms that I can combine for my final answer. So since I have 2x to the first, I can add those together and I'm going to get 9x, and then I'm just left with this plus 72 here. So now we need to make sure that we simplify our like terms before calling it a day. Now double check that this is in standard form. I have a degree of 1 and a degree of 0, so we're good to go. On number 8, notice how I have distribution going on here, and then it's being added to distribution going on over here. So not only are we going to have to distribute, much like we did on number 7, we're going to have to combine some like terms. So let's start by just distributing like normal. I'm going to take this 3 times x squared, and I'm going to get 3x squared. Then I'll take 3 times 4x, and I'll get 12x. Then I'm going to bring down this plus sign, and I'll distribute this x throughout my second binomial. So x times x gives me x squared, and x times negative 15 gives me a negative 15x. Now, to combine like terms, they have to have the exact same variable raised to the exact same exponent. So here I have an x squared and an x squared. These two are like terms. They can be added together. Now when you add them, you only add their coefficients. The variables stay the same. So 3x squared plus x squared gives me 4x squared. Then if you look at what I have left, I have a 12x and a negative 15x. Again, they have the exact same variable raised to the exact same exponent. So I can add those together to get negative 3x. Finally, I just need to make sure that it's in standard form. So this first term has a degree of 2, this second term has a degree of 1, so we're okay. What I'd like you to do next is pause the video and try number 9 on your own. Alright, hopefully you distributed that n through and got 2n squared plus 9n. And then you distributed this negative 6 through your second binomial, and you got negative 6n plus 6. Then when you went to combine like terms, you only have one term with an n squared, so that's going to give you 2n squared. You have a 9n and a negative 6n, which gives you positive 3n. And then you're just left with your plus 6. Now double check that it's in standard form. Degree of 2, 1, 0. We're good to go. On number 10, I hope you notice that we're working with two different variables here. I have an x and an a. Now when you're multiplying two different variables together, it's really important that you write them in alphabetical order. Because if I'm multiplying an a times a b, and I get a b, that is technically the same thing as b times a, which is ba. Now since these are technically the same thing, that means that they would be like terms, and so I could add them together. But at first glance, you wouldn't assume that they're like terms because the variables are in a different order. Now that being said, we need to make sure that we always write them in alphabetical order so I can easily look at them and identify what goes together. So on number 10, when I multiply x times 2a, I want to make sure that's in alphabetical order, so I want that to say 2a x, with the a coming before the x. Then I can multiply the x times 1 to get x. Now in my second distribution, I want to take 6a times negative x, multiply the coefficients to get a negative 6, and then your variables need to go in alphabetical order, a times x. And then I'll take the 6a times 9 to get 54a. Now I can combine my like terms. So if you'll notice, this 2ax and this negative 6ax, those are like terms because they both have an a and an x to the first power. So I can combine those to get negative 4ax. Then my remaining two terms, I have a positive x and a positive 54a. They are not like terms. So I'm just going to bring them both down. Now you can put the plus x plus 54a. Those do not have to be in alphabetical order because they're not being multiplied together. So let's check that this polynomial is in standard form. I have an a to the first and an x to the first, which gives me a degree of 2. I have an x to the first, which gives me a degree of 1, and I have a 54a to the first, which gives me a degree of 1. So this is in standard form. On number 11, I've got a little bit more complicated polynomial as I've got some crazy exponents, but that's okay. We're going to handle it just like normal. So I have a 4x cubed y squared being multiplied by a 3x to the 8th y to the 4th. I'm going to start with the coefficients, and 4 times 3 gives me 12. Then I'm going to take x to the 3rd and multiply it by x to the 8th, which means I need to add those exponents to get x to the 11th. Finally, I take y squared times y to the 4th, which gives me y to the 6th. Now I'm going to take this 4x cubed y to the 2nd and multiply it by negative x. So 4 times negative 1 gives me a negative 4. X to the third times x gives me x to the fourth, and I can bring down my y squared. Finally, I can drop down this plus 7x to the 11th, y to the 6th, because it's not being multiplied by the original monomial. Now I just need to go through and combine my like terms. My first term has x to the 11th, y to the 6th. And to be able to add that to anything else in my polynomial, it has to have the exact same variables raised to the exact same exponents. So this one, even though it does have an x and a y, it's not being raised to the 11th power and the 6th power, so they're not like terms. But this guy here has an x and a y raised to the 11th and the 6th power. So these guys are like terms, and I can add them together to get 19, then x to the 11th, y to the 6th. Finally, that leaves me with my third term, which can come straight down and say minus x to the fourth, y squared. Last thing before we move on, we just need to make sure it's in standard form. So I have an exponent of 11 and an exponent of 6, which gives me a degree of 17, and an exponent of 4 and an exponent of 2 to give me a degree of 6. So this one definitely has a higher degree of this one. It's in the right order. Now what I'd like you to do is on number 12, pause the video and try that one on your own. Hopefully when you distributed, you got 3x squared plus 6x minus 7x squared minus 7x. When we combine like terms, the 3x squared and the negative 7x squared will give me negative 4x squared, and then the 6x and the negative 7 will give me a negative x. The next thing I want to talk about is what happens if we kind of go the other way. So here we have a monomial being multiplied by a binomial, but I'm missing a part of the binomial. Now, instead of us finding the answer, they gave us the answer, and we have to find out what I'm missing. So if you guys follow what we have been doing, we know that we're going to take this 2 times x to get 2x, and I need to take 2 times something to get this 18. Well, obviously in your head, you know that 2 times 9 gives you 18, so that has to be 9. But if we were to follow a mathematical process, what we're really doing is taking this term here and dividing it by whatever is being distributed, 2. So 18 divided by 2 is 9. Now this process is going to help us with this one on number 14. That's a little bit trickier. I know that I need to take 6n times something, and I'm going to be left with a 24n squared. So I need to take that 24n squared and divide it by this 6n to see what I'm missing. Now I know that 24 divided by 6 is 4, but I have to figure out what n squared divided by n is. Remember, you subtract those exponents, and if I have n squared and I'm taking away n to the first, that means I'm left with n to the first. Now you can always double check to make sure you did it correctly. Is 6n times 4n 24n squared? 6 times 4 is 24, n times n is n squared. On number 15, instead of giving us what term they're distributing by, they give us the binomial and they give us what we end up with. So I just need to choose one of my terms and divide it by whatever else is left. So I don't really want to deal with variables. I'm just going to focus on the constants. If I take this constant of negative 21 and divide it by this constant of 7, that's going to give me a negative 3. So my answer is negative 3. Finally, on number 16 and 17, they give us a rectangle and they want us to find the area. They were nice enough to give us the formula. We just have to substitute in. So it says area equals length times width. Now the length and width of the rectangle don't really matter which one's which. I'm just going to choose. I'm going to let 7 be my length and 4x plus 3 be my width. So I'm going to substitute that in. If I say 7 is my length and 4x plus 3 is my width, to solve, I just have to distribute. So 7 times 4x gives me 28x, and 7 times 3 gives me 21. Finally, since this is an area, I just need to make sure I give it a label. They didn't give me a label to start with, which means this is going to be units. But since it's squared, or since it's area, that means it's squared. And then one more thing, I need to make sure that I understand that it's not just 21 that's units, this is the whole thing that's the area. So I'm going to put it in parentheses. This binomial is my area in units squared. Let's try it again on number 17. Again, I'm starting with area equals length times width. So if I notice, I'm just going to call this guy my length and this guy my width. Notice when it's a monomial and a binomial, I find that it's easier to make the monomial my length and the binomial my width, because then that helps with my distribution property. If you make this your length and this your width, it'll still work, but it's not going to be as easy or as smooth. So if I substitute my 5y in for my length, and my 12y plus 7 in for my width, I can distribute through, and I'm going to get 60y squared plus 35y, and then my label again would be units squared for my area.